Okay, now that we have spent some time learning how to use radicals to offset powers, how to convert radicals to rational exponents, and how to simplify radicals and rational exponents, now we can use all of those skills in solving equations. And so now we can have an equation where we're trying to solve for a variable that could have a radical or an exponent in it, and we have skills and tools to be able to eliminate whatever is surrounding the variable. So when we do this, we spend a lot of time, as you've seen before. If I had x squared equal to 4, in this case we were taking the square root of both sides to get the x value, and remember that left us with a plus or minus 2. Now we're kind of flipping that scenario. Now we may have a situation where we have the square root of x equals to 4, and so we would offset that with the power of 2. And so the same thing happens here. If I have a root of 2 that cancels out a power, the power of 2 is going to cancel out this root, thus giving me x is equal to 16. Now, sometimes whenever you're squaring two sides of an equation, you may end up with a binomial that is squared, which will leave you a quadratic. So be very careful of something called an extraneous solution. One of the two solutions from the quadratic may not be a real solution. So you just need to be aware of that and be sure to check all of your solutions. Now, just as we could square or square root, we could do that with a cube and cube root, and so forth with higher degree roots and polynomials. So let's take a look at a couple examples here. So you can look at example number 1. Just like we did back in Algebra 1 when we tried to isolate the variable, what we're really trying to do here is isolate the variable that has the root with it. And once we do that, not until we do that, can we use the necessary power to offset that root. So you can see at this point, once that part is isolated, we can then raise both sides to a power of 3. Now that's a good example of a root. Example 2 is an example of a rational exponent. And so what happens here is a little bit different. We want to try to isolate the x value that is being raised to the 3/2 power. So the first thing that happens is we divide both sides by 2. Now, if you notice, we didn't use radicals here. What we did is we used a reciprocal. And so you can see this is the reciprocal of the given power. And the reason we use the reciprocal is because a power of a power, we use the multiplication, and you're going to end up getting 6 over 6, which equals to 1. So that's technically leaving us x to the first power by using that reciprocal power. So this is a good example of rational exponent. So what I'd like you to do is just take your time, go ahead and work through sample problem 1, and then come back and take a look at the given answers. Okay. So for part A, the first thing we're looking to do is we're looking to isolate the variable that has the root with it. Now we can do this in one of a couple ways. If you're one of those type of people who likes to have the variable on the left side, you can move everything else over to the right. Or if you're just looking for the quickest way to make that positive, what I can do is I can actually add that to both sides, and that gets rid of the negative for me. Now what I'll need to do is I'll need to raise that to the 4th power, because if I raise this root to the 4th power, it's going to cancel, but also have to do that to both sides. So that cancels, leaving me x, and 5 to the 4th power is 625, and you can use your calculator for that if you don't know those roots yet and powers. Okay, for part B, we need to isolate that variable, and we have to start by dividing by 3, so we get x to the 4/3 power equals to 81. So since we have a rational exponent, we want to raise it to a power that is the reciprocal power, and we have to do that to both sides. Now, those 3's cancel out, those 4's cancel out, leaving you a 1. So I'm going to have 81 to the 3/4 power. Again, You can use your calculator for this, and if you punch that straight in your calculator, you'll get x is equal to 27. So that's the first sample problem using roots and rational exponents and powers to solve radical equations.